The strategies for keeping Bitcoin secure and keeping Lightning secure are really pretty different. And so we realized that there was something missing, and that much more had to be done for Lightning because it's fundamentally more challenging than Bitcoin. The secrets are in a smaller program that's running on a more secure computer. Very specifically, it doesn't have thousands of connections to many other nodes. Like, it only has a single connection to the one node that it's protecting. We have to be able to do all of the signing operations and store all of the necessary secrets using multi-party computation. So that's where Taproot and Usig and Frost come in. All of a sudden, companies like Netflix are going to have 50-gallon drums filled with nickels filling really fast, and so they're going to need VLS to be secure. If there's no money at all, then there's no danger and no one cares. But as soon as there's money to be stolen, the people who steal money will come. So you need to increase your security game.
Ken Sedgwick is a software engineer on the Validating Lightning Signer project, a project focused on improving Lightning custody by separating keys from nodes in a discrete signing device. In our conversation, we explored what VLS is, why it is important to the Lightning ecosystem. We talked about why it is much harder to build discrete signing devices on Lightning rather than on chain. We talked about some of the challenges that are being solved to enable seamless multi-party signing on Lightning nodes. And we talked about the future of custody and security on the Lightning network. If you enjoy this episode and if you learn something new, the best way you can show your support for this show is by sending in sats over the Lightning network. You can use any Podcasting 2.0 app to do that. There are dozens of them out there, but my favorite one to use is Fountain. Before we get into today's show, just a quick message from our sponsors. Today's show is sponsored by Voltage. Voltage is the premier provider of Bitcoin and Lightning node infrastructure. Today's show is also sponsored by Stackwork. And Stackwork is a Lightning-powered transcription tool that takes the best of AIs and humans to create better, faster, and less expensive transcripts. We'll have more from Voltage and Stackwork later in the show. Ken, welcome to the show. I am so excited to talk about VLS and the work you're doing. But before we get into all of that, let's start with your background. Can you give folks a little understanding of your life prior to, let's say, Bitcoin?
So I was a software engineer. Actually, originally my degree was in hardware engineering, but that only lasted for a few years before I switched to software. And then for many, many years, I worked in Unix, threading, parallel processing, so mostly throughput engineering for stuff in the back racks. In the 90s, I became a consultant and did lots and lots of consulting since then. Again, mostly Unix, mostly threading, performance, tuning, fixing bugs, that kind of stuff. In 2011 or something, I had been hearing about Bitcoin. And then in 2013, I heard about it again. And I said, now, wait a minute. This must be real, because look at all this market cap they have. If it was broken and you could trivially take it, then it wouldn't have that value. And so I took a really long look at it, detailed, got involved, and then decided, okay, I want to do more of this. And so I wrote an Android wallet. So I was inspired by Electrum. I said, this is the way wallets should be, but we really need an Android solution. And so I set a goal of trying to learn things and meet people, and wrote a wallet. And eventually, I decided not to be the wallet provider to end all wallet providers, but I did meet people and learn things. And in that in wallet development, I met Dev Random, who's the other co-founder of VLS. And we've worked on, half a dozen different projects over the years. And then most recently in I'm going to get the dates wrong, but 2017 or something, right before VLS, we did a company named Base Zero, which was oriented towards Bitcoin custody. So helping enterprises and finance companies who were not familiar with Bitcoin, trying to teach best practices and offer hardware and software to do that well. So Dev Random and myself are both very custody oriented. So wallets, how to keep it safe, security engineering. There's a whole bunch of related things that you have to be good at in order to completely secure Bitcoin. Then we started thinking about Lightning. And I mean, that's where it gets really interesting, because the strategies for keeping Bitcoin secure and keeping Lightning secure are really pretty different. And so we realized that there was something missing, and that much more had to be done for Lightning, because it's fundamentally more challenging than Bitcoin in a bunch of ways. Should I just keep going here?
That's great.
If I'm on a good trajectory, there's more
I have
here.
so many questions already, but first, I want to hear more about some of these companies you started in between, from the first wallet to VLS. You said there was about half a dozen companies you guys had worked on.
Projects.
All Bitcoin related?
Only one company. In fact, it's important to say VLS is not a company. VLS is an open source project. There is no corporate anything. We are looking for people to join us and help. Everything is completely open, yada, yada, yada. Base Zero, the thing before VLS, was a company. And that was a company focused on making hardware and software solutions for doing custody. Prior to that, something worth mentioning, we did a colored coins effort back in 2014 with Peter Todd. And we learned a whole bunch there. That was really pretty fun, and met people and learned things. That's what it's all about. So
that's awesome.
Yep.
So talk to me about Lightning. What first drew you to Lightning and made you think to yourself, yeah, I've got to be building on this. This is the next interesting thing worth working on?
Well, Bitcoin is wonderful, of course, but it has several things that it doesn't do terribly well, because it's decentralized. So it's a trade-off. But in order to be decentralized, it loses out in performance and then some cost issues. And so when I first learned about Lightning, it's like a big aha. Oh, this fixes the three biggest problems of Bitcoin. Maybe it certainly fixes latency. So you can imagine fast transactions with Lightning where you can really not imagine them with Bitcoin. And then you can imagine the fees can drop to very, very little with Lightning. Should be less than 1%. So probably not enough to even think about very much. And then finally, there's some auxiliary benefits to Lightning. So it improves privacy in a lot of ways. And there's other things, but it became clear to me, and I think DevRandom as well, that it was essential for Lightning to succeed in order for Bitcoin to succeed. So we, just like in networking and operating systems and other things, you build things in stacks where the lower levels are fundamental and simple and primitive, and then you get more refined and add more features as you stack things up. And so Lightning is a natural level 2 for Bitcoin, which brings very important features. And so it's critical. As we looked at it, we then went, oh boy, the security is harder though. so thus VLS. We started talking about what you do to secure it and what do you need. And a reoccurring theme was that since Lightning wallets are hot, meaning that they must have the key material readily available and constantly using them. So even when they're not terribly active, they still need to sign things because the fee market might change, and so you have to rewrite the commitments with new fees and stuff like that. Mm-hmm. So maybe I should spend a minute about the differences between Bitcoin and Lightning security. Does that seem like good?
Yeah. Let's touch on that first, and then we'll get into VLS specifically.
Sure. Yeah, I'll make this pretty quick. So Bitcoin, the main strategy, if you're an enterprise or anybody doing a lot of Bitcoin transactions, is to keep the vast majority of your stash cold, so not in the hot wallet at all. So, for example, exchanges frequently have 95 or 98% even of their funds cold, which is cold storage is a relatively straightforward thing to understand. You can tell when you're doing it right, and it's easy to see how no one can get it as long as as your security assumptions are correct. So that's the basic idea behind Bitcoin security. You then make the hot wallet as secure as possible, but the biggest piece of that is making sure there just isn't much in there that doesn't need to be in there. Just like banks don't keep all the money upstairs if there even is an upstairs to any banks anymore. So Lightning is different. So a quick example is if you had a large retailer, and let's say they had 1 million channels, so customers had open channels to them to pay stuff, and each of those channels had $100 in it. Suddenly you have a machine or a small group of machines that have $100 million of funds with keys that are hot. So those machines, if you gain access to those machines, is one way to put it, you can send that money to yourself. And so that's not good. And so we were trying to figure out how can we make that so that doesn't happen.
Now let's get into what VLS is specifically doing, because there's, I think, a lot of parallels between the cold storage you see on chain and the VLS project. Can you speak a bit, just like at a high level, about what VLS is working towards?
The basic idea of VLS is to take all of the secrets in a node, so fundamentally the keys, but then there are a few secrets as well, and extract them and put them in a separate, more secure program, which is then connected to the node and has a live connection to the node. So whenever the node needs to do something that involves signing or using a secret somehow, it's going to ask the signer, VLS, to perform that operation for it. VLS then provides the signature, and the node, off you go. So already that's better because the secrets are in a smaller program that's running on a more secure computer. Very specifically, it doesn't have thousands of connections to many other nodes. Like, it only has a single connection to the one node that it's protecting. And that connection can, in fact, it's best if it's something like a serial cable or a very specific internet connection that does not allow routing anywhere else or anybody else to get to it. So your VLS node is reducing the attack surface and running in a more secured environment. And so by doing that, you fundamentally make it harder for the attacker to get at the keys. But we got to go another step. That's the easy part, actually. The problem is the hacker can still take over the node. So the VLS security model that we use, like when we're worrying about what's secure and what's not, is we presume that the node has been taken over by a hacker, can do anything he wants on that node. So VLS needs to protect the user. VLS actually needs to be very thoughtful about what it signs. And that's the validating part, the V in the validating Lightning Signer. If you're not doing the validations, then you're blind signing, meaning that it's like you're rubber stamping. So somebody comes to you with a check and you don't even look at it. You just say, sign it. And while that still may be good because the signature stamp isn't, generally available, it's not that good because the bad guy can just bring in a bogus check where it pays him all the money, or pays to the wrong person, wrong amount, and all that stuff. So VLS is very specifically keeping all of the state about a Lightning channel straight in its head. So when it sees any action that the user is taking, so if a commitment comes and the commitment represents making a payment, so that's actually offering an HTLC to another node, VLS is going to look and make sure that that payment is in your interest. How do we do that? So we have an allow list, which lists all of the destinations that are unconditionally safe in your world. Those can be layer 1 Bitcoin addresses. So if you're a company, your cold wallet would be there. You would put an XPub in and list that address. So you can always send money to your cold wallet because it's configured as an allowable address in VLS. Another thing is you might have multiple nodes at your company. Think of them as a team. So 5 nodes and they all work together. So each of those nodes would know about the other nodes and would know that it's okay to send money back and forth without any further justification because all of those nodes represent the same financial entity. So it's okay. The overriding concept inside VLS is looking at what the beneficial value of a transaction is delivering. So when it goes to do something, we say, well, let's say you're opening a channel. So we can say, we see that you're putting 0.1 Bitcoin into this channel from your wallet. So you're down 0.1, but we also see that you are gaining 0.1 channel liquidity. And so that's to your benefit. And those are balanced. And so that's okay.
Interesting.
A quick example of where we could cut off something is if we had a mutual close. So the node says to us, okay, we want to close this channel. but we noticed that the address that it's sending the funds to isn't in either your either the wallet that VLS controls itself, so your online wallet for that node, or in the allow list, or asks you. Actually, if those two things don't match, it if you're on a device and have a screen, will pop up and say, "Hey, do you mean to send this payment or close to this address?" And you can say yes or no. In an enterprise situation, there would be an API there that would connect to something that can approve that sort of an exceptional transaction.
I see. So is it right to say then, similar to how an on-chain hardware signing device is a separate device for signing, this VLS, you're building the software, but there will be a separate device for people to make signatures, and the only difference being that Lightning being hot, this device is going to be connected to the internet. Is that correct?
It's very similar. So with a Bitcoin wallet, you have a Trezor or Ledger or a Cold Card, your hardware wallet, and you connect it to the laptop, for example, to do the transaction. In that time, it's actually a little bit hot, right? Because it is connected to your laptop, but it is much harder to attack because it's connected through, again, a serial cable, USB serial or similar. And it has a trusted display. That's another big deal. So a bad guy will take over your computer and he'll show you that he's doing the right thing on the screen, but he's really building a transaction that does some bad thing. Well, your hardware wallet defeats that by showing you what the transaction actually does. So VLS is exactly doing the same thing, but the difference is that a Lightning node always needs to be on. So if your laptop was running a Lightning node, you would have your VLS hardware device always plugged in. So it's only different in how often you have it plugged in. It needs to always be there. But otherwise, it's completely analogous. The keys are in the hardware wallet. The hardware wallet has to scrutinize the thing, the transaction. The hardware wallet will use a trusted display or trusted channel to approve things if that's required, and then it makes it so if those conditions are met. VLS is exactly doing those same things. I would say the amount of state and the amount of complexity is like it's 100 times more complicated. Bitcoin wallets are simple compared to Lightning wallets because Lightning has a bunch of state and it's just that's our job. We have to learn all that and do it correctly.
I fear we may be going a little bit over my head in terms of the technical content here, but I'm going to ask anyways. What is it that makes it 100 times more complex to do this on Lightning rather than on Bitcoin?
Well, to begin with, the Lightning wallet does all of the layer 1 transactions just like a Bitcoin wallet. So you start off with at least that much. The next thing is Lightning channels are represented by multi-sig commitments. And so it's like a multi-sig wallet, which is a little bit more complicated than your normal hardware wallet. And then the big thing is understanding that there's a fairly complex protocol that's outlined in the bolts, which describes many messages which reflect changing fee markets, all sorts of different operational. So the other side may want to close, you may want to close, you may have to unilaterally close. There may have been a breach, which is part of the Lightning network, and so you have to respond to that. On and on and on. So it just has a lot more protocol related to it. And another thing is the Lightning network is adding features at a significant rate lately. So, we can go through Bolt 12 is emerging. We've got splicing coming up, all kinds of good stuff. Whereas the Bitcoin network moves more slowly. So, Taproot was sort of the last big thing that happened to Bitcoin wallets. And that was, a couple of years ago. It's been happening for a while.
Right.
So in order to do VLS, you have to track all of the, current protocol stuff that people want to use because the VLS needs to be up to speed and be able to do that.
Yeah. So now we're about 5 or so years into Lightning. Why is VLS coming out now? It's now in beta, I believe. What's the reason that we've taken 5 years to get to the point where we have, some external signing device and Because I wasn't around in the earliest days of Bitcoin, but I believe we did have that before in the first 5 years.
Let's see. Actually, so the Trezor came out in 2013. I think
Okay, so that's
so.
not far. That's 4 years.
Yeah, back then I was developing a wallet, so they sent me an early model without a case so that I could, plug it in, like a developer kit thing, and that must have been 2013 or maybe 2014. So you're right. I mean, but it still takes time to develop the hardware and write the software. Now, this software is much more complicated, so it's going to take more time to do that. The hardware needs to be a little more. It needs more memory because there's more stuff to hold. Other than that, I don't think it's. Actually, we should take a step back for a second. VLS can run on a wide range of things, so it's happy to run on small embedded devices that don't have secure elements and all that, but are still more secure because they're not the main computer and they're running a non-standard OS, maybe a primitive OS, which is good because that is harder to attack.
So maybe is it true then that we are now seeing this push towards external signing devices and Lightning because now maybe the stakes are just high enough that it warrants this kind of like effort, and in Bitcoin maybe the same was true in the first few years where there wasn't much of a market cap in those first couple of years. It's like what's the point?
I think you hit the nail on the head. I mean, it's exactly it. So if you're exploring Lightning and someone says, well, we need to put $1,000 in this sample node, people will just do it and play with it, and because your time is more valuable than that amount of money. But now let's say your business is sort of getting some traction and you have some good ideas and you're asking for investment and you want to scale it up. And then folks realize, well, you're going to have $10 million in liquidity in a set of Lightning nodes. And suddenly the folks who think about this sort of thing say, well, hey, what are you doing for security? How do we know that you're not simply going to get hacked and they're going to take the $10 million? So it's become an issue as folks have become successful and the business models have grown, and you start to imagine bigger nodes. Devren and I got here by imagining what it would be to have a large retailer, as I mentioned earlier, because it's easy to imagine those guys having millions of channels. Now, maybe the retailer doesn't have a million channels. Maybe they partner with someone who does a million channels, and then they just have one big channel between them. But somebody has to do millions of channels. And whoever that is going to have hundreds of millions of dollars sort of right off the bat. And so they're hopefully worrying about that, and they want to know what is the best practice. And so we're trying to say the best practice involves VLS. You're going to separate your signing. So you'll have your nodes, and they'll be in one computer center, and they're busy connecting to everything in the world, very busy, very high performance network, all that kind of stuff. And then in a more secured place, you're going to run a VLS server, which does the signing for those nodes. And it connects to them through very deliberate, very specific connections. So it's not like general purpose, sockets. Nobody else can get to that secured machine. There's a cool separation of concerns in here because the ops team can run the nodes and they should be able to do everything they need to do, like move money from here to there. Let's bring this node up. Let's open a channel. Let's close a channel. VLS is happy with all that stuff because it can see that those operations don't lose you money. But the finance department controls VLS. And so the guys with the fiduciary responsibility now can say, I don't know anything about the node operation and I don't need to know, but I can look at the VLS system and see that I have $10 million, in hand right now. VLS will certify how much money it thinks it's controlling right now. And that's good because also there's some policies involved. So some of the security policies we use are velocity limits, for example, because velocity limits are generally useful. They're like circuit breakers or fuses. So even when stuff happens that you didn't think about, so whatever, like a bad address went into into an allow list, or somebody approves something, you might say just limit it to never send more than $10,000 a day. You have to tune that, shrink wrap that to your business model. But that then says when we do get hacked, it's not like bang, it's all gone. Suddenly, instead, it's you've had a bad day. They've taken, 1% of your funds instead of 90% of your funds.
Right. Who is VLS for? Is it for enterprises, or are you targeting anyone who's interacting with Lightning? Who might use this?
Actually, VLS represents custody. So another way of saying what we're doing is Lightning has routing and gossip and all these other things going on, but we are extracting just the custody part, just the ability to control the funds and to say, I control these funds. And if I don't trust my node anymore, I can go to a different thing, a different program, and get my money because I have the VLS signer and it can recover those funds. So since it represents custody, that actually opens up some new ideas. So an end user might have a Lightning node, but the way that node might be implemented is that all they really possess is a VLS signer, and then they connect to the node which is being operated for them in the cloud. And that makes a lot of sense in a lot of ways because the nodes need lots of network bandwidth and CPU cycles and all this other stuff. And what you want to do is take the least amount of stuff out of there that represents custody and just run that in the user's possession. It might be a phone, it might be an embedded device. This is an SDK for an STM32. There's ESP32 stuff being done by Stackwork and Sphinx for exactly this purpose. And so then this is a very low end thing. This is a consumer would have a somewhat secure device. These are not exotically secure things, but they're much more secure than just having something on your laptop, because those can be hacked with conventional techniques, and then the bad guy gets away.
Yeah. Do you think that we'll see any of the existing hardware signing devices, the Trezors, the Ledgers, the cold cards, any of them venture into this kind of Lightning custody space?
We hope so. I mean, so we're not hardware guys, but we are clearly writing the software with the intention that it go in hardware. And so, in fact, this thing I held up is a little demo board that we use. So we have a proof of concept that runs VLS in this STM32. It's to prove that you can make it small and run in hardware. If those companies, when they become interested, we're hoping that they will come talk to us and use the software, and they have more hardware expertise, and there's a wide variety of devices. Like some are going to be much more secure. I mean, there's HSM manufacturers that make the stuff that corporations use now to sign the very, very important things they have. But HSMs are difficult to develop for directly because you have to sign NDAs and they require lots of special stuff, and they're very proprietary. So we're building VLS will be able to run there, but initially we're making it so that it runs in more open stuff. But it's definitely designed to run in a variety of hardware encapsulations. That's important. It really wants to be in secured hardware.
I see. Now, why have you chosen to build VLS in Rust? Is there something? Is it inherently more secure than any other languages?
I don't want to trigger a religious. Yes, though Rust is more secure. Rust has a very revolutionary kind of model for how it manages memory and objects, and so it does not require programmers to. It tells you when you're doing it wrong, and it requires you to do it right. And so actually, when you first start writing in Rust, it's going to take you a lot longer to do some initial things, because you learn that Rust is not going to accept something where it's sloppy or loose with respect to who owns which object. It's very clear in Rust. It's enforced by the compiler. And then that means that it doesn't have buffer overruns and that sort of kind of bug. Those are actually the most common bugs, I think, still in a lot of places. So Rust doesn't guarantee something secure. You can still write insecure things in Rust. You can take the secret and print it to a port, and that would be wrong. But it does encourage careful thinking about objects and all that sort of stuff. The second thing to say is Rust has a much smaller system integration assumption than many other environments. So in Rust, there's this thing called no STD. No STD means that this program will not assume that it has the standard libraries that you have on all Unix machines. So writing to files, writing to the network, clocks, that sort of stuff are not assumed. And then you then add those explicitly based on whatever embedded device you're in. But that model in Rust means that it's really easy to port to embedded devices, because embedded devices just say, hey, I'm no STD. I don't give you any of that stuff, so don't ask for it. And then you're bringing your own in terms of, you've rolled your own. So for example, in this device, we wrote our own serial handler so that we could handle the serial port. So it's a simple serial protocol on both ends that sends command requests in one way and responses go the other. We did not. It doesn't use gRPC on that device.
Do you think we'll see other teams try and build out similar projects to VLS in different languages, similar to how we see a number of different Lightning node implementations in different languages?
Possibly, but we're really hoping that everybody just uses VLS. I mean, that's the point of being open. We don't have any proprietary control over it. People are welcome to come and, you could, if you don't agree with us about something, you can fork it and do it your way. Hopefully, we keep that in check. We'd like to keep it all together. We're currently working with Core Lightning quite closely. So we're integrated with the current Core Lightning releases. We work with LDK quite closely. In fact, we use LDK object definitions and all sorts of stuff. We're basically an LDK extraction, if you will. So we should work very well with any node which has been built on LDK should be able to have VLS signing relatively straightforward. We've got a sample node called LNROD up on our repository, which shows that. So it is a node, a Lightning node built with LDK, and it uses VLS. LND has been going a different way for a while, but recently there's a project called LND Signer, and it's being done by NYDIG. I don't know if that are they, whatever, NYDIG. Oh, yeah. And they are now working towards a proxy, the proxy will be in the LND side, but it will convert to VLS protocol. So it will connect to VLS when that proxy is functional. It's worth saying that with CLN, it's a proxy as well. So what we did with CLN had a daemon. CLN is made up of a bunch of cooperating processes, one for each channel. There's a master process, yada, yada. But one of the daemons was called the HSM daemon. And as Rusty said, it was aspirational. He said, someday there should be an HSM here, but today there's just a process. Well, we saw that and went, oh, wow, okay. So we pulled that daemon out and replaced it with our own. And our daemon simply forwards the request to a connected VLS signer. So when you're using the CLN thing, we are supplying a proxy which looks to CLN just like its own native HSMD, but in fact, all of the security requests are being farmed out to the VLS signer, and then the signatures are being given back.
Mm. Why does it make sense to run VLS as an open source project rather than turn it into a company? What's the distinction there? Why'd you make that choice?
Well, with security stuff, let's see. First of all, the code has to be open. I mean, there's so many shades of what does open source mean, and some of it's control and some of it's visibility. So let's first talk about visibility, because it's just a no-brainer. I don't think anybody can use a proprietary, opaque, black box thing, and where they say, just trust us, this is in here, because things are changing too quickly, and you have to go in and look to verify yourself. So the code has to be open. The next question is, well, why not have a proprietary control over it? Why not try to extract value through the normal techniques? And the answer is, Devran and I really want it to succeed. And in order to succeed, we have to make it so that anyone who wants something like this is going to be better off using this than writing their own. Now, if we raise the bar and say, well, we're only charging $1,000 a month now, pretty quickly they'll be doing the math and saying, well, I think I can write that for less than that. Or So we don't think that we don't want to be involved with the monetization part right now. We really want to get VLS adopted by everyone and connected to everyone. And we want everyone to help look at it and make sure it's secure, file bugs if it's not, and add features if there's something you want it to do. I think down the road, the way that myself and Dev Random and other people like us would make money is we would do obvious consulting and adding features for hire and support. There's all this regular kind of support stuff where, if people are using VLS, then they're going to need it to be adapted to their situation. They're going to need you to build something that connects to it, on and on and on. And so, we're not going to starve. We're not in this to try to, this is not about getting rich. This is about fixing an important Lightning problem and making sure that everybody can, that the Lightning Network succeeds. We want everyone to be able to use this.
Mm-hmm. And now, I believe until now, you've received a couple of grants, correct? That this has been a funding mechanism for the meantime?
Correct. So we were initially self-funded, and maybe that lasted a year or something. And then Square, now Spiral, maybe it was Square and then Block, and that's, anyways, now Spiral has generously given us a grant. Actually, won a year for 2-3 years. It's been a while, and they've been renewing. And Blockstream has also given us a grant. The Blockstream one is also interesting to point out that we're working with Greenlight. So Greenlight is a way for the node to be in the cloud and the user to have as small a piece as possible. So that's the Greenlight vision. And so that's very similar to the VLS vision. And when we talked to them about it for a while, they said, oh, well, VLS should be the signer in the Greenlight system. And so it is.
I hope you're enjoying the show so far. Just a quick message from our sponsor, Voltage. Voltage empowers engineers to integrate Bitcoin and Lightning Network payments into their business stack with an enterprise-grade experience. The team at Voltage is building the complete toolset so that you can do more than simply spin up nodes, but also understand and interpret your node's data. Their new product, Surge, gives engineers the capability to quickly solve problems and optimize operations. With node insights and visibility through time series data, you get dynamic and complex insights never available before. You can get complete control with insanely fast onboarding, advanced client-side encryption, and zero management infrastructure, making backups, networking, and upgrades simple. Get a free 7-day trial today at voltage.cloud. One thing I want to talk about is security breaches in Lightning. I want to talk about, we talk about this concern of losing funds and, how you're trying to make custody better on Lightning. What are some of the examples of some of the biggest breaches and losses of funds to date in the Lightning ecosystem? Because I don't hear much about it. I hear all the time in crypto, there's some DeFi project that gets hacked, but I haven't heard much in Lightning.
Actually, to be honest, I haven't either. What I do see a constant drumbeat of is folks who've lost their funds due to operational problems. So they weren't attacked, but instead their node crashed, and then they restored from a backup. And of course, that doesn't work in Lightning because the state's even slightly old. Then you've committed a breach, and then your channel funds are taken. Anyway, so yeah, there's a lot of accidental loss right now, but I am not aware of any directed attack that was successful. Now, it's quite possible there have been, and whoever was attacked decided it was either embarrassing or bad for their reputation to admit it. But frankly, that doesn't disturb me. I think Lightning is still very, very early. Like the explosive killer app that's going to make the Lightning Network explode is going to happen the end of this year or next year. It hasn't happened yet. With Ethereum, you could look and say, oh, remember CryptoKitties? That was an explosively successful thing in 2018, was it? It brought the Ethereum network to its knees, but then it made everybody wake up and go, oh, wow, there's something going on here. And so NFTs came out of that. And so there was a lot of DeFi and other kinds of stuff. And now it's easy to argue that they got out past their security boundary, if you will, because there have been hundreds of hacks of DeFi. So the Bitcoin maximalists and the Lightning people are different, right? We're trying to move very slowly and carefully, trying not to get the cart before the horse and all the excitement, so that you end up with a very dangerous situation. So DevRandom and I feel that we have to move really quickly here because there's going to be a point where everyone will need VLS, but we we just need to be really close at the, almost done or really done, or you're starting to really get it going at that point. We're getting there right about now. So I think we're ready for an explosively successful killer app for Lightning. And when the publisher turns around and says, hey, wow, my node is now, accepting $100,000 a day, and I'd love to hear some story about how to make this more secure, we're ready to talk to them. So we've been, working ahead of time, if you will, trying to make sure we're ready. It's been a lot of work. I mean, we've been coding for 3.5 years, I think. Yeah.
What do you think the explosively successful killer Lightning app will be?
My opinion is this, no more valid than, everybody else. So I think it's going to be L402. I really do. I've been thinking that for a long time. And then recently when that, sorry, the screen did it again. I think it's Lightning Labs introduced the white paper, but L402 is a concept that can be done with any node, with any system. The basic idea of putting a proxy in front of content that today uses a subscription model and saying, well, you can still use a subscription model, but there's an alternative model now. You can do anonymous, one-time. Instead of renting the movie and you must watch it in the next 48 hours, you're going to say, I'm just going to pay you $0.05 a minute to watch the movie. and I don't have to know who you are. I don't care. I mean, I think it's a great business model and everybody's going to be excited by it. It services a lot of people's needs. So that might be it. It could be a lot of things.
A lot of the excitement about L402s right now seems to be around AI. Do you think that will be the kind of tool that unlocks L402s for everyone?
I don't know. AI has a lot of hype right now. So there's a lot of attention and all that kind of stuff. So it doesn't hurt to, focus the L402 tool at whatever has attention. It doesn't weaken it at all. L402 is remarkably general. You can put it in front of anything. And then we hope to see, complete integration with web wallets and stuff like that, which should allow folks to start, a la carte instead of, you know what I mean? But instead of having an account at Netflix and arguing about like how many people are in your family, instead it's just going to be, give us $0.05 to watch the movie. We don't care if you watch it in the next 48 hours or just watch 10 minutes and stop watching and watch something else. It works better for everybody. But all of a sudden, companies like Netflix are going to have, 50-gallon drums filled with nickels filling really fast. And so they're going to need VLS to be secure.
Right. What other things can Lightning node operators do to reduce the kind of operational risks or the risk of an error that they make? As you mentioned, some of the losses of funds may have been operational errors and not hacks. What other steps can operators take to reduce that operational error surface area?
So I'm going to draw an analogy to being a pilot. So airplanes, there's all different kinds, and some are simpler and some are much more complicated. But on the complex end, pilots are expected to be trained to use them. You don't just step in and fly a 707. you do time. You do a lot of book learning, and there's some time in a simulator. I'm not a pilot, so I don't know. But I know that they're complaining that it takes too long to train pilots lately. The analogy, though, is that Lightning nodes are not trivial to operate. You need to understand more stuff. So we need, as developers, need to make them easier to use and work on the documentation, especially, and the training techniques to make sure that folks understand what's going on. The fundamental, the very basic one that everyone learns right away is in every other computer thing, a really good idea is to have a backup where you back it up as often as you can, and then you can switch to you use the backup if something happens to your node, or have a buddy node, which is ready to stand in if the primary node goes down. So just everything else uses that. Lightning can't do that, doesn't do that because of the breach problem. And so suddenly the fundamental security model of everything else doesn't apply to Lightning. And so it requires a bunch of training and understanding on how to make that work. So if you are a person learning about Lightning, my recommendation is run it in testnet or run small amounts in mainnet and practice, go through the chops, make sure you know how to get liquidity, make sure you understand how to make a payment, make sure you know how to do various node operations. Like, this channel doesn't seem to be good, so I should, close it and open a different channel. There's a lot to learn in there. Operating a Lightning node is harder than operating a Bitcoin node, for sure.
Mm-hmm.
So, yeah, we have to
And
get
do you
there.
ever do you see a point in time in which it's no longer going to require the training that it does? Like, I know in the airline example, we still have pilots, but maybe there is a day in which we have autopilot and there's no training required. Is that something that we can get to in Lightning?
Absolutely, from the consumer end. So if I want to make Lightning payments and I'm not interested in running it, I don't know any of those words. It's a little bit like the phone and the internet. Like, in the old days, you had to understand the internet and how to dial up and how to all kinds of stuff. And nowadays, just everything on your phone uses the internet, and you don't even think about it. And people who don't understand it, doesn't matter. They can still click the icon and chat with their friends or exchange stuff. So from the end user thing of making a payment, I think we're going to completely wrap that. You won't even have to know it's Lightning, and you can do it. On the very other end of the spectrum, though, in the enterprise where your business is accepting, Lightning payments. A good example is merchant payments now. That's not free. All merchant systems require a small amount of development support to get it set up, and then there's someone who tends to it and can debug it. And those merchant things fail all the time, and people are panicked because we can't accept credit card payments right now. And so, really good stores, like if you go to Target or Walmart, their credit card stuff is being run by a very, very thoughtful, trained, highly experts who know what they're doing. And Lightning will be just like that. Different, but you're going to have expertise and do it correctly if you want to be on the enterprise, the big business side, and receive a lot of money. An interesting midpoint is, well, what about small retailers, coffee shops, all those guys? How will that work for them? I think the emerging answer is that we're going to see Lightning service providers. So these are going to be companies that bundle all of the Lightning operations. Like, they know what version of software they're running. They know which features you're using. They know all that stuff. But the store owner will then utilize that to send and receive Lightning payments, mostly receive. But here's the important part. If they use VLS, then the store owner can have custody. So the store owner would still have some form of VLS encapsulated device. And that keeps their funds safe, meaning they don't have to trust whoever their LSP is. The LSP cannot steal their money. That's really different than today's merchant accounts. If your merchant provider wants to steal your money, they obviously can, but then you're going to have to go prove and argue, and people do. With Lightning, it's possible to make it so if you're using VLS, you have custody of your funds, and you could go to a different provider and use your same node and same VLS signer and use your funds there. That's the vision.
Wow. So what changes do you think that introduces to the merchant landscape if now merchants no longer have to argue with PayPal or argue with whoever about whether or not a transaction was valid, or to unfreeze their funds if they're operating in an industry that isn't approved? What changes will we see to commerce now that a merchant can fully control their funds?
Well, just like the internet disintermediated a whole bunch of middlemen for the travel industry, go through book-selling industry, unfortunately. I'm hopeful that Lightning and Bitcoin will disintermediate the ugly parts of banking, right? The part where they hold the money, they give you a hard time about everything. And basically, it seems like it's impossible to send money or receive money without working with an uncooperative, large, surly company that regularly pays hundreds of $1 million fines for doing bad things to their customers. Not saying
right.
Yeah. Anyway,
And
not mentioning any names, but I think it's all of them actually. So it should empower the merchant because the merchant has choices. They're no longer, tied to a merchant account, and it should hopefully disintermediate the rest of the credit card infrastructure.
mm-hmm.
That's the goal, because it'll work better. It will. It can't work
Yeah.
worse.
Do you think there are any changes that we'll see to the structure or the kind of composition of the Lightning Network when we have some of these like custody improvements enabled by VLS? Like, will we see the actual structure or the connections between different nodes on the network? Will that look different?
Absolutely. In fact, I don't think anybody is really quite sure what it's going to look like. And that's okay. There's arguments. And so we're working very hard to make sure that there are not centralizing pressures. What we want to make sure is that you don't have to do it in a centralized way. Some of us feel it's okay if something is a little bit centralized in the early going, especially as long as it's not compelled to be centralized. So, it's okay to have some sort of service initially, which isn't, completely distributed. This is me talking here. It's my opinion, because the merchants will have options going forward, and so different things will emerge. Today, your credit card agreements don't allow you to consider other things, so it's locked in by the powers that be. So the merchants are not fighting; they're not negotiating in a good faith place with other people who are making. You're basically over a barrel, and you either do credit cards or you don't. What will the connectivity look like? It might be more centralized. It might not. We don't know yet. No, I mean, a really big question is there money to be made here by regular folks running routing nodes, for example? So similar to mining other cryptocurrencies or doing any of the DeFi things that you could do to try to get some return on your capital. Certainly, you can run a routing node and you put capital in, and then you get some payback. So far we have not seen that being very rewarding. It's hard to really pay for your effort to do that. I think that's actually good, to be honest. I don't think we should have a gold rush right now with just a whole bunch of people trying to run it and basically competing to set up more stuff that they don't understand, because that's where you get these bad outcomes where people who really weren't thinking about it got really in deep.
Right. And do you think then that we look at the Lightning Network today? It's 5,000 Bitcoin of public capacity, an unknown amount of private capacity. Are there people who are sitting on the sidelines who are wanting to participate but have not yet because something like VLS hasn't existed?
I think so. One thing that we see, and I'm going to leave out all the names here because I'm always nervous, don't want to, but we've been having a large number of meetings lately where we're talking to someone who has been asked to come talk to us because the compliance department, the risk management team on their effort has said that they don't like that Lightning node. It looks dangerous, and they're right. And we say yes, that's right. So what you should do is continue using Lightning and understanding it, and so on and so forth, and start working with VLS to understand how we can fit it into your enterprise. So yeah,
right.
As the amount of money increases, if there's no money at all, then there's no danger and no one cares. But as soon as there's money to be stolen, the people who steal money will come. So you need to increase your security game.
Mm-hmm. Okay, I want to talk a little bit about multi-sig. This is featured throughout your website. I want to talk about the importance of having multiple signers being able to manage a Lightning node. Why is that? Why does that matter?
Let me first distinguish they're two completely different things. And one will happen much sooner, and let's call that alternative signing or cooperative signing. And then the other one, I'll avoid using multi-sig because the other one will be multi-party signing or multi-party computation. And that one's a little more distant, but also very exciting. but for different reasons. So the first one is a cooperative signing idea. So let me outline this very quickly by saying it's possible with a small device like this one or something on your phone to store the state. You would store it on the device as well, but you could also keep it in the cloud. And so there is a protocol for that VLS uses when it connects to a LSS or VSS signer. So the VSS signer is probably the one to talk about, which is a versioned something store. And so it's in the cloud, and the signer is sending encrypted state, and there's some authentication, so the signer knows that it's getting the right state back. And that gives you a couple things. One is it gives you a backup. So if your device goes completely missing, again, like Bitcoin, you would need to know a seed. So there's going to be this one-time seed storage thing. But if you know the seed, you can get all of the other state from the cloud and then pick back up right where you were. But there's also a different thing you could do. You could have two devices. One might be your phone, for example, and the other might be in your house. And either of them can do the operation. So that gets you some redundancy, but it gets you a lot of flexibility too, because if there is a bit something where you have to approve something, it might depend where you are. One thing might be better. What's a good? Oh, for example, for receiving funds, it'd be nice to have something always on in your house because if you want to give me money, great, I'll sign that. Whereas on your phone, it's very difficult to have either a node or the signer or anything running all the time on a phone. Both Apple and Android aren't very good at keeping stuff running in the background. So they're intermittently connected at best. But a phone might be a great way to make payments though. So you want to authorize a payment to go out, that's what you do on your phone. So those two devices could be the same VLS state, if you want to think of it that way. They're just alternate engines, but they're using the same state, and they're coordinating rendezvousing via VSS, the cloud storage that's storing the state. So that's coming up relatively soon. Everybody's interested in it because it gives you backups and it gives you some nice alternatives. You can say use one device for receiving and another one for sending. Let me talk about the other thing though, the multi-party thing. Now the multi-party thing is really an enterprise thing. So if you want to make something even more secure, so the first thing you did was you took the secrets out of the node and you put them in a secure computation environment, and you made it. You put barbed wire around it and guard dogs and stuff. So, but even better than that is split it into 5 things, and none of them has what it takes to do the signing itself. They have to cooperatively sign. So it might be that 3 of them have to be online and cooperative in order to get signatures happening. And now the bad guy can attack and either take 2 of them offline or even steal outright 2 of them, and they still can't steal your money. So that becomes extremely secure. An enterprise would likely put those 5 cooperating signers in different locations and use possibly different tech stacks to do it, different hardware, and maybe even different surrounding operating systems, because that makes the attack harder. If they're all identical and I find some way into one, I've got some way into all of them. But if they're all a little different, then the bad guy has to come up with a different attack, and he needs to get to 3 of them. So now you've really made that job difficult. You've made that to be a very secure system. Now, to do that, though, we have to be able to do all of the signing operations and store all of the necessary secrets using multi-party computation. So that's where Taproot and Musig and Frost come in. So those are all ways for a group of people to generate a signature where none of them has sole ability to generate the signature. There's a lot of work in that area because it's not some of the inners of the Lightning protocol do not lend themselves directly to multi-party computation. But the VLS team we have a matrix chat group, and we have folks from all over the place, from all the different ventures. So there's folks from Spiral there, there's folks from Core Lightning there, and and these issues are being discussed, and we're coming up with solutions. I'm actually not the best resource on the ins and outs of Frost, recursive musig versus Frost. But what I see happening is that we're finding ways to handle some of the problems and make it work in a multi-party computation thing. And I would say, I think in a year's time, we're going to start to see that happening. There's a bunch of foundational stuff that needs to get settled in. People need to. Everyone talks about Taproot and Musig and Frost all the time, but especially Musig and Frost are actually fairly new, and people are working very hard to understand them and get enough track record with them so that they feel that those solutions are secure. One thing that the experts talk about a lot is whether there's a security proof for the particular recursive proposal, yada, yada. And in most cases, there is not yet a security proof. So at some point, someone will do that proof, and then everyone can go, yes, okay, now we know it's secure, and we know that there isn't going to be a problem there.
Mm. And what changes do you think multi-sig in either of its forms will have on the Lightning Network? Like, what does that actually do? Is it makes enterprises maybe more secure? Does it change the way they behave? Does it change the way consumers behave?
We feel it's best if your peer, your counterparty, can't tell that you're doing that. So it will look exactly the same when you're using it. So it does not change the Lightning protocol. We want to do the multi-party computation thing, especially using the existing protocol. Now, an important thing's happening. Lightning Network is moving to adopt Taproot, so it's going to change the way some of the internals work, and it gets a bunch of advantages from that. And that part is getting designed right now to make it so that you can do multi-party computation without revealing that it's multi-party computation. At least until there's a unilateral close. Sometimes with the unilateral closes, there can be a trade-off where if we make it so that you could tell that it was multi-party, you make it a little bit simpler. And unilateral closes are hopefully less frequent. Right now, there's been a bunch of them, and we're trying to make sure that the different nodes are working to make less forced closes.
I hope you're enjoying the show so far. Just a quick message from our sponsor, Stackwork. Stackwork is a Lightning-powered platform for generating high-quality transcripts of all your audio or video content. They combine AI engines and hundreds of human workers all over the world who are paid over the Lightning Network to assemble these transcripts. And that's what lets Stackwork create better, faster, and less expensive transcripts. To see the results for yourself, you can check out my personal website where I host transcripts for all my podcast episodes. If you want to learn more about Stackwork, visit stackwork.com. That is STAK work.com. Do you foresee in the VLS project, do you think that you will at some point venture into hardware? I know you're focused on software right now, but is there a path for you to, because you mentioned your very first kind of training was in hardware?
Well, that was with through-hole components that went, you drilled holes in the boards and stuck them through. Surface mount can't. I'm really old. Yeah. No, we don't. We would work with a hardware partner to do that. And I think the partnership is sort of obvious, right? I can imagine all kinds of companies that already sell a related project. So they have marketing arms and they know how to package and all this other stuff that we don't know anything about. And we've actually are going to solve the hard part for them, though, which is we're going to have a time-tested set of software that they can trust to put in there. I think customers will be more comfortable, in fact, if a product has a open source standard component running inside it, rather than something proprietary from the vendor. Some of them are proprietary now, some are open, but almost none of them share the exact same software with each other. And I think that would actually be better. So if I were buying a hardware device and it used VLS, but I knew that there were other hardware devices that also use VLS, it would make me feel much better because I would know that if I end up not liking this hardware, I can switch to one of those, but I don't have to start over. I can reuse my same stuff. So
I want to ask one question about your roadmap. On your site, you mentioned the debut of a VLS enhanced stackwork. And you mentioned stackwork at the beginning of the episode. I'd love to hear more about that if you're able to share.
Sure. So Stackwork / Sphinx, those are the same engineering team who we work with, and then I'm a little weaker on the marketing side of which things are associated with which company. Though their interest is in providing Lightning services to small merchants or people doing small tasks. So it would be used for sending tips or small amounts of money for different reasons. Some of them might be like social networking, and other might be I'm paying you to do something for me. So I'm a little unclear on that business model, but I know all about what they're trying to do technically. So they've built a ESP32 board which runs VLS and connects, I believe, via Wi-Fi to a cloud, a node that's running in the cloud. And so Paul, the founder of Sphinx and Stackwork, tweeted, if you look, and it might have been almost a year ago, a picture of a wall wart plugged into his house that was actually doing that. At TabConf last year, I believe they did a workshop and they, gave out 30 of these devices. So these are consumer devices. They're not expensive. I mean, maybe it's $10 a part, something cheap. And probably if the quantity goes up, it falls a whole bunch more. So the idea there that they're running with is to use VLS to minimize the custody. In other words, distill the custody down into the smallest possible thing so they can run it in the smallest device, most inexpensive device. And that would provide Lightning services to their community.
Right. And then their community is now in full control of their funds.
Correct. They don't have to trust Stackwork and Sphinx.
Right.
And that's really cool.
Yeah, that is very cool. What other items? I know you have a few other things on your roadmap listed, but anything else you're particularly excited about that you want to share with folks today?
Well, I'll speak more generally. So VLS can run in really tiny devices, really big devices. What we've been doing originally was writing it in the simplest possible way. So you write the most straightforward code to implement the VLS validation and signing and stuff. But we then need to tune it for particular runtime choices. So we just went through a milestone where we tuned it for low resource signers. And so that means take the same software, which was written simply, and now do the optimization to make it run in much less RAM. So you're looking for, where can I reduce duplication? Where can I compress something? Where can I adjust the lifetime of something so I don't have to hold it any longer? And that was critical for Stackwork and Sphinx because they're running on small devices. On our roadmap in the very near future is probably throughput tuning. So that's the other end. So if you're a large retailer, the obvious question is, how many payments per second can I receive if I'm using VLS? And so we need to go tune that and make that as fast as we can make it. And then we need to know what the number is so we can tell people, well, if you run on this kind of hardware, we can go this fast.
How fast do you think you can
that's
make
ahead of us. We measure and then we understand and then we go, make it better is the way we work. I don't want to guess.
Yeah, that's fair.
I think it's fine. Actually, when you look at the amount of money that people spend on keeping things secure and building, there's plenty of resources at the high end. In other words, you're not worrying about running on some tiny amount of RAM. You can have everything in RAM if you want, and you probably will. So we want to be able to be tuned either way. Another one is channels are fundamentally independent. So if I've got 1 million channels, I should be able to do many of them in parallel, sending or receiving payments. And that's attractive. We have to make sure in the code, though, that we don't have any hidden choke points or other things like that. And that's actually the kind of work I had done for all of my consulting before crypto even. So it's fun to do. It's interesting work. And there's advantages that come. If you can tune your stuff so it goes faster than everybody else's, that people will go with your product or your thing.
Right.
So,
All right. I want to finish this off with a couple rapid fire questions for you. You ready?
okay.
First
All duck.
question. If you could only hold one asset for the next decade and it could not be Bitcoin, what asset would it be?
Probably Zcash.
Interesting. I haven't heard Zcash before. Is there one book that has meaningfully changed your view of the world?
Oh, Dawkins, The Selfish Gene.
Oh, okay. That's a good one.
If you mean in crypto or technology, it'd be
Any
something else
book.
maybe, but
Yeah.
still Dawkins. And, even affects how we think about programming sometimes.
Very interesting. If you could give one piece of advice to builders in the Lightning ecosystem, what would that be?
Start small, get involved, practice, and work your way up. Don't spec out some giant thing that's all complicated without any of it working. That's not the way to get at this stuff. So you start with just and start small, work large, keep practicing, keep learning.
Nice. And then finally, who is one builder in the Bitcoin or Lightning ecosystem that you'd like to give a shout out to for doing great work?
I can't do just one because, actually, it's important to say VLS, our primary challenge as a team is that we have to integrate with all the other teams. So it's a really important thing. Like we have to know how to do it without stubbing too many toes. People have to make changes to their node code to work with us, and so we got. I think we're very lucky to work with multiple different teams with really good people. So the core Lightning team is top notch. The LDK team, which we're meet with every week, top notch. L&D guys we've known the longest, and they're really great. And then I've been meeting and learning, meeting the async guys, and they're wonderful. And the cool thing about the Lightning world right now is, although everybody's competing in some sense, we really are very cooperative. We get together and we talk about things. If you find a problem in somebody else's thing, you don't embarrass them. You instead work with them to help them get it fixed. We all want everyone to succeed.
Yeah.
So it sounds all very, yada, yada, but it's true. It really is like that. And VLS, we're of no use all by ourselves. We have to run with a node and with other things. So VLS is a pilot fish, and it needs a shark. So we have to work with the other groups. And I feel very lucky to work with these teams. They're very, very smart people working very productively and doing really good stuff. It's very exciting.
Yeah. I've heard from multiple implementations and multiple teams that there is this collaborative nature. This really, it really is a collaborative kind of community right now, which is very cool. You're right.
Yeah, it absolutely is. Yep.
All right. Before you go, where can folks go to learn more about you and VLS?
So the simplest thing is our website, vls.tech. So vls.tech. And that has all the links to all the other things. So if you're interested in documentation, there's documentation links in there. There's links to the repository. There's to the demos and proof of concepts of things. Maybe most importantly, there's links to the matrix groups. So if you have more questions or are interested and want to get involved but don't even know how, come chat with us, and we'll see how you fit in, or if we can solve your problem.
Awesome. Thank you so much for taking the time to chat today. I learned a ton.
Thank you, Kevin.
It was a blast. Hope we can do it again soon.
Thank you for having us. Yeah, absolutely.
In the last 30 days, you guys sent in 42,591 sats, and that came in from 41 different supporters. Now, I just posted an episode a couple of days ago, so I haven't had any new comments since then, but I can't wait to see what you guys send in this week.